Okay, great. So, yeah, let's begin. Uh, Good afternoon, everyone, and a very warm welcome to today's webinar. Today's webinar is Introduction to Adapt PTRC, Streamline Design for Post-Tension Beams and Slabs. Uh, I'm Ashwin Nagar from Acero Consulting Engineers. Acero Consulting Engineers is the channel partners for Nimishek Group, and Nimishek is the parent company for Adapt PTRC, Adapt Builder, RISA, Bluebeam, and other software solutions. So this session is an introduction to Adapt PTRC, a powerful solution that helps structural engineers like yourselves and consultants streamline the design of post-tension beams and slabs while ensuring accuracy, compliance, and speed. So thank you all once again for joining us here this afternoon. Let's get started. So let me quickly walk you through today's agenda. We will begin with a brief introduction of Adapt PTRC, followed by its key technical features and supported standards. Then we will move on to the live showcase of the software where we demonstrate the workflow step by step. We will also cover practical applications so that you can relate to your project and touch upon the licensing and software support as well. Finally, we will wrap up with some Q&As. So here is what we are hoping that you will get after the end of by the end of the session. We hope that you will have a clear understanding of what Adapt PTRC can do and how it fits into your design workflow. We will walk you through its core capabilities and so you can confidently use it in reinforce and post-tension concrete design. You will also get a sense of best practices to improve efficiency and ensure reliable results in your projects. Finally, we will also be sharing some resource materials like documentations, tutorials, and a participation certificate in the end. So do stick with us till the end of the meeting. So let's move ahead. Before we begin, I'd like to introduce you to today's presenter. Our today's presenter will be Mr. Kirti Chandra Joshi. He is a structural engineer at Acero Consulting Engineers. Kirti holds an MTech in structures. There's Kirti. Hi, Kirti. Uh, he holds an MTech in structures from Delhi Technological University and has hands-on experience with multiple softwares that we sell, like RISA, Adapt, Bluebeam, Idea Statica, and IFM, and many more. So he'll be taking you through the detailed technical walkthrough in just a bit. Before that, we would like to tell you more about what Acero is. So before we dive into the product, Acero, we are proud to have worked with more than 300 clients and delivered more than 30 products and supported more than 20 plus locations. Our team is essentially made up of postgraduates from top engineering universities. And we like to enhance our clients' productivity, streamline your workflows, and get the most economical solution to your problems as possible. Right? We do that through regular knowledge poster webinars and resources like these ones. As you can see, right? Coming to what are the softwares that we deal in. So let me give you a quick overview of the broader ecosystem that we are a part of. So starting with Adapt PTRC, which is focusing on design and post-tension, design of post-tension and reinforced concrete beams and slabs. So Adapt Builder is also a part of it. So Adapt Builder is a separate software which is for comprehensive PT design, and Adapt Flight is for load takedown and distribution. On the analysis side, we have RISA 3D. It handles full structural modeling along with RISA floor, foundation, and connection for detailing design workflows. For documentation, we have Bluebeam, and Allplan is a BIM-based design software for architects and engineers. So these are all the solutions that are offered through Acero under our Nimishek portfolio. Along with these, we also have solutions like Autodesk, which you all might be familiar with. We have Idea Statica, which is a steel connection design software. Other softwares like Adobe, Trinity from Weaver as well. So with that quick overview and introduction to all our softwares, I would not like to take any much of your time and hand over to Kirti. Kirti will take you through the software's core features and its capabilities. So thank you all once again for joining us. Kirti, over to you. Thank you.
Yeah, thank you, Ashwin. I hope I'm audible, right?
Yeah, you're all.
Yeah, hi, good afternoon, everyone. So my name is Kirti Chandra Joshi, and from here I will, take you into the technical aspect of the ADAPT PTRC software. Yeah, so it is a software, specifically for the design and analysis of a post-tension or reinforced concrete beams and slabs. Like as you all know, like when we design the flow system, like we are balancing between the strength and the serviceability condition. So as in the post tensioning, the challenge is not just calculating the moments, but understanding how the tendon forces interact with the structural behavior over time. So we check the spans and revise the tendon forces, control the deflections, and again we check the stress again and again. So as a part of our design, iteration process. So as seen on the slide, you can carry out the different types of the project in the ADAPT PTRC, including the reinforced concrete and the PT beams. It may be the one-way or the two-way slabs, the waffle and the pen joist. So as well as the continuous, beam frame system. So this software is also good for long span structures where the serviceability requirement such as the deflections, cracking, and the stress controls become governing rather than the strength alone. So all the systems can be analyzed within the ADAPT PTRC, and I believe that it definitely helps to achieve the efficient and the economical long span concrete design. So here are some of the key features of the ADAPT PTRC. The first is it supports the wide range of product, like the project, like I mentioned. It can be, it allows us to design the different concrete beams and the slab system. The second is the it's interactive model definitions where we can easily define the spans, the supports, and the boundary conditions, the loads, and all the details related to the reinforcement and the tendons, so that we can make any like we can make the model updates whenever any design changes occur. So yeah, another important features is its design capability, which helps us to check out the stress, the deflections, the reinforcement, and the tendon profiles. And regarding the analysis, the software also will captures the crack deflection, the losses, the elongations, and the momentary distributions, like which are critical in the concrete design. So the next is the code support. So analysis and design checks are directly, like the design checks are directly aligned with the standard design codes that follows the Indian standard along with the ACI, Eurocode, and the other international standard. So moving forward, like it supports the Indian code, like I mentioned, IS 456 and IS 1343 for the RCC and the pre-stress concrete, as well as it also supports the other international design standard. So, that makes it the globally adaptable tool that may be suitable for both your local and international projects. So you can also observe the modeling and the report snips on the slide, like which shows like how the layouts, tendons layout, analysis results, and the reports are generated. So I mean, like from modeling to the documentations, like everything, uh, making the PT design more efficient and optimized using the ADAPT PTRC. So we'll also have a more detailed look on our software demonstration part as we move forward the webinar. So before moving, like here are some of the additional capabilities of the ADAPT PTRC. The first one I would like to highlight is its interactive tendon layout. If you are working with the PT, where we can easily adjust the tendon force and its profile, its shapes, and we can observe like how it affects the overall design. And next is the software supports both the bonded and the unbonded tendon, like which is useful for when different PT system are used in the project. And the next one I would like to highlight is it includes the load balancing and the PT recycling, where pre-stressing is used to balance a portion of the dead load. Like if you are all, working on the PT, you might be familiar with all these terms. So there is a built-in tendon profile library, such as it might be parabola, the reverse parabola, or the straight shape, so that we can select the standards and modify them like whenever we require. And you can also carry out the punching share and the one-way share check. For example, like checking the slab, for when checking the slab safety around your columns, where the shear failures are usually critical. So it allows us to check the one-way and the two-way shear check. And obviously, it also analyzed the PT element for the losses, elongations, and the secondary effects, like I mentioned. So we'll also see all of this in our demonstration part. So who actually benefits from the PT, ADAPT PTRC? So like if I highlight, well, mostly the structural engineers and the designers and the PT consultants working with the concrete, like whether the RCC or the post-tension system, like dealing with the slabs and the beam design. So it also benefits the consultants and the checking engineers, like, since the reports are clear and detailed, and the verifications, it might make the verification process much smoother. So like overall, ADAPT supports everyone involved in the concrete design. And if you're already using the ADAPT in a project, like maybe you can just write a yes in the comment box. So just to understand like how many of the experienced users we have here today. So regarding the modeling and the analysis, so in ADAPT, you can work in an interactive slab and the beam modeling. Like you can simply define the geometry, the supports, it might be the loads and the tendon layout. Then once you define these, then the software performs the analysis and helps you to check out the stress, the deflection, the pre-stress losses, and the overall behavior. And it allows also for the modification of the tendon profiles and supports the PT recycling, like where you can reuse and optimize the tendon forces during the iterations, just to achieve an efficient design. So we'll also see all this clearly in our demonstration part, step by step, from modeling to the report generation. And once the analysis is completed, like it provides the a detailed presentation and the reporting options. Like you can generate the reports with both the graphical as well as the numerical results. So I've also added some of the snips in the slide. And it allows also for the DXF export of the like the tendons and the reinforcement, like which can be useful for the drawings and the coordinations. And you can review the detailed results like the moments, deflections, or the stress, the reinforcement informations, along with the code reference. So yeah, let's see all of this workflow from modeling to the reporting in the ADAPT software itself in the next slide. So we'll see a brief overview of the ADAPT PTRC and how you can use this tool to quickly design the beams and the slab. So once you click on the software, you have the interface where you can select your post tension of the mild reinforcement. So I am just clicking on the PT design. So I will just click on PT and will click on OK. So the new tabs will open where you can set out your new project. So now AdaptPT is, basically a 2D frame program. So which means we are going to be modeling the strips of the slabs along the support lines, or we can do the full beam run that we'll see today. And once you have this interface, you can see there is the option of one-way slab, two-way slab, and the beam. And in the upper portion, you can see the cross here, where in the below generally will provide the modeling input. And once you provide the modeling input, the model will be displayed at the top. So as you can see, the top one is the person. So there is the options for the beam, one-way slab and the two-way slab. And once you click on any of these options, the input sections automatically changes based on this one-way slab, two-way slab, and the beam. So we'll go for the beam today. And once you click on the tools options at the top, you can just select or convert your units. For example, if you use the American units, then you will be able to set off your American code. And if you use the SI unit, then you will be able to use the Indian code as well. That let's see how this work. Like you have the options of converting unit. So I will just click on start with selecting the SI unit as of now, but we'll change it for ACI and we'll see how it affects the code seg values. And I'm just starting it with giving a general title beam design at the rate Acero and just giving your name, just giving my name Kirti Chandra Joshi, and I will just click on the beam options. And as you can see, while clicking on the beam option, you can see the input parameters here. Like if you enter a beam and if you want to consider the effective width in bending, you can just click on yes, but you can change all of these settings and later you can view, like if you click on yes, then the effective width can be calculated as per the ACI code or European code, or you can definitely assign the user defined values. This screen will be popped up like but as I understand that the ACI code does not require that effective flange width to be used for the pre-stressed beam, but we'll just click on yes just to showcase like what will be the next tabs available when we go for these options. So yeah. Once you set out this, you can just click on next and you have the options of defining the different codes. Like you can see there are the American code as well as the Indian codes are also available. Here you can see IS 13433 test coding is there. Since we have selected the SI units, that's why we are able to see the Indian code. But if we have selected only the American unit, then only the American codes would have been displayed. So that is the setting you can control. But today we'll go for the ACI code and we'll just click on next. And once you click on this, then you will see the design setting options like is on the screen. And you can set, you can, get more information on this as well. But since it's in the execution mode, you can see the automatic and the like the interactive options are there. So basically in the automatic mode, like the programs, attempts to select the post tensioning forces and yeah, the profile based on the parameter specified by the users. And in the interactive, like the it helps to optimize the design by adjusting the tendon force and the tendon drafts in the span. So if you like to know more information about this, you can just go on the help sections at the top and you can just click on about like the documentation tab, and you will get the user's manual directly from the softwares. And once you open that, you will able to get all of this information and how this can what's the meaning of that informations. So once you click on that, you will get all the project and the modeling overview like you can see on the screen. So this is the same tab that is been displayed on the PDF folders. So you will get all the information directly from the information tab. So by now I'm clicking it on the interactive, and let's go to the span geometry. This is the sections, where you can define your number of spans. So once you define your spans, and in the modeling portion, it will be displayed. Like right now, we have not defined any of the span. That's why you are not seeing any of the models in the above, but we'll define the number of the span to the 6 number of the spans, and we'll just give its dimensions as well. And you have the options to define the left cantilever and the right cantilever as well. So you can see, you can define the different types of the sections. As of now, I have considered it as a T sections, but you can change it to the rectangular sections and the other sections as well. Like it is basically the 2D environment, like the 2D software. So right now I'm just checking, changing the code to the American. Right now you can see the no Indian codes has been visible when we select the American code. You can just drag it out just to adjust your window, just to fit all this within a window. Now we are going to give the length of the spans, the width of the beam, the height of the beam, like the depth of the beam. Span of the 32 feet, I am giving it, and the beam width and depth of 20 and 22 inch, and BF is the tributary width. And now you can see there is the options of yum as well in like yum. Basically, these are the left and the right multipliers that indicates, the number of times your unit strips need to be multiplied to cover your left and the right tributaries. And basically the tributary width BS I have defined is composed of both your left and the right tributary, and the RS values indicates your distance from the reference line to the top of your slab. Basically the reference height we set is equal to the depth, so I'm just keeping it a depth of 22. And once you click on enter, it will be applicable to all the spans. So basically at the top, it is a typical. So once you provide data in the typical, you can just click on enter and it will be same for your 6 span, like span 1 to 6. So once you set out this, you can see your modeling has been displayed at the top, and you have the options to view it in elevation view, the plan view, and the wireframe view, or the isometric view. So this is the wireframe view with the tendon. So we will also see the, we'll also set out the tendon forces, the tendon data, the profiles also. So I mean, like once you provide the input through input, then you will be able to see the modelings accordingly. You can definitely rotate it. So you can set it as per your requirement, like the view you which you want to set it out, and you can also zoom in and zoom out. So then you can select on next, and this is the effective flange width. Since at the beginning, when we select the beam and it asks for effective flange width, do you want to consider? So we have selected the yes. That's why this tab have been popped up. So it will it have the options to calculate it for the ACI European code, and you can also put your user input values as well. But we are selecting it as per the ACI code. And once you click on next, then you can define your columns at the, you can define the columns at the lower columns and above columns, like above and below and above the beam. You can assign your columns, and also you have the options to select the no columns, but we'll set up with the lower columns. And you will get all the informations at the top as well, like the what the parameter is actually, like what the B value is, what the S1 value is. So you will have all the information here itself or in the documentation as well. So we are going it to give the height of our column as the 12 feet, and we can assign the rectangular column as well as the circular column. So I'm just going it with the circular columns of 25-inch diameter. So once you define the columns, you can see in the modeling environment, the column has been modeled. And here is the percentage tab as well. That basically is you can define the stiffness, column stiffness, as well. So once you click on next, then you can assign the supports, the boundary condition for your column. So one is fixed, two is pin, and three is the roller. So we are going to keep each as a pin. So we will select the number two and going to give a enter so that it will display it for all columns. Right now we have assigned the column as a pin. And this is the tab where you can, define your load. So you have multiple spans, and if you want to apply the load, combined load for all the spans, you can just simply type all, and you can just select the class like the superimposed dead load, the live load, and you can just give a value of it, your loading. I'm going to create a load for the superimposed dead load, and going to give a load value. So since you can see there are the uniform load, the partial uniform, the concentrated load options is there. So once you simply drag each any of them and put it into the required rows, uh, the one way is that. Otherwise, you can just simply type the, since you can see the letter LU is for uniform, so that you can simply type U within the rows, and it will be assigned as a uniform load. So you can just simply change by giving it a numerical value like the alphabetical values. So once you click on P, then it will be the partial uniform. We are going it to give a uniform value, so we'll just write it with U, and we are going to give a load values of 20 and the 40 PSF, and we simply click on next. And in the beam, basically you can see, you can define your the concrete type as well. So you can select all of these informations, like depending on the code, the concrete weight classification is used, and which can be used in the shear and the flexible flexible calculations. So you can define your reinforcement here. So I'm going it with the number 6 bar at the top and number 7 bar at the bottom. And this is where you can define your pre-stressing. Like you can define the post-tensioning system type, like the both bonded and the unbonded. Like when we use this, the program calculates the effective stress and the stress used like in the tendons, and then it determines the effective force per strain used to calculate the final force in the PT recycler. PT recycler that we are that will also show. So I'm just checking of half inch diameter of the unbonded tendons, and this is regarding the base reinforcement. So like if you have the already the existing slab condition, you can just go for the base reinforcement, and once you click on yes, then you will have all the additional details like typically used for the existing slab conditions. And if you want to provide extra reinforcement at the bottoms and meshing of a slab, this is the stress values you can define. Basically, the tension and the compression stress, like they are the multiplier of the square root of the FC values, and compression stress are generally entered as a multiple of FC. And these values, entered are for the final allowable stress that will be shown on the stress compression and tension tab of the recycler window. We'll also see that. So I'm going for a maximum of the 12 for my total stress, and all the keeping values the same. And this is for the like basically for the pre-compression values, the minimum and the maximum values of the pre-compression you can set that the program will be used to determine the post-tensioning requirement. Like I mentioned, it specifies to uh, put the values for the minimum and the maximum values for every pre-compression, and and the percentage of the dead load to balance, we'll just keep it as a 50% up to the 100% of the dead load to balance. So once you set out this, you can just click on next, and you will have the options of two options are there, like the force selections and calculate the force per tendon selections. Like it may be like the force selection is the default options. Like to use the tendon selection, it calculate like to use the tendon selection, like I mentioned, it calculates the number of tendons per like it calculates the force per number of tendons. You can use that options, and if you use that option, the screen will be prompted for the information to calculate the pre-stress loss is seen on the screen. Like this long-term losses, you can see this may be entered as a lump sum value, or the information required to calculate them may be entered as well. So we'll check it with the force selections, and once you click on this, then you are going to see the shapes for your tendons. The multiple shapes are there, like the parabola, reverse parabola, the straight. Like here you can define the tendon shapes, like basically the transfer girdles and the slabs with the heavy concentrated loads may require the half shape, as shown in the number 3 options. So once you select the tendon type, for example, you can definitely, as of now, I have given the parabolic shape, but if you want to change it, the number 4 is the straight. By this way, you can change, but I'm just keeping it as a reverse, like the parabola shape. So this is the details you can just put for your post tensioning, and the criteria for the bar length that can be used to calculate the top and the bottom bar lengths when minimum reinforcement requirement are governing. So this is regarding the criteria for the curtailment, basically that it determines the minimum bar length for the calculated reinforcement. Basically that will be from the location of your zero moment. And at the last, you have the options to set out the load combinations, and you can also include the lateral load as well, as you can see here. Once you click on this, then you have the options to set out the values. So once you have provided all this input, now you can see there is a no next options available. So you can just click on OK. The modeling portion is almost completed. So once you click on OK, then you can just save your models, and we'll run the models, and we'll see the results and the report. So we can just simply run the analysis by clicking on the buttons available under the file options. It will take some time to run the analysis. Now you can see the PT recycling window has been opened, and it is going to see you the minimum PT force that we have entered and the balance load condition that we have saved, like the 25%, like the 50% and to the 100%. So accordingly that the PC recycler window has been opened, and it will check all of these values. As you can see, the required PT force is 330, and we have provided quite more. So that's why it is giving me okay. But if we change the value, if we bring down the values to the 320, and it will, now you can see the recycle options has been popped up at the top with the red symbols. And once you again recycle it, then it will show me it is not okay for the PT force. So let's check this. So you can just click on the recycle. So you can see the PT recycler that the required, what is the required force and what is the force we have provided, then it will again recycle it. So this is the stress regarding for the initial stress condition and for the service stress conditions, service load conditions, you can see. You will get all this information. And once you click on this cycle again right now, you can see this check value will be updated. Right now, you can see the PT force is shown as the NG, which is not good. But once we provide it a value of more than 330, so we are providing it as 340. Now it will again fix that issue. You can check the other parameters as well. So once you click on this exit options, you will have a new window opens where you can you have the options to display the graphs for your bending moments, stress, the deflections, and you will have the options of generating the summary and the detailed report as well. So once you click, it will give you the information like which icons related to which informations, and once you click on the respective informations, you can get a summary by clicking on the yellow icons. It will give you the summary of your beam design. Once you click on OK, then you are going to give all your names, the envelope, and the elevation view, the top rebar, and the profile, the required rebar, the provided rebars, the shear reinforcement. So you will get all the information. And the next one is the deflections. You will get all the deflections value as well. And you have the options to export it to the DXF as well. Once you click on the DXF options, so you can go again back and you can also generate a report. And also you can generate the bending moment by simply clicking on any of these icons. Like once you run the analysis, you will have all the informations in the graphical form as well as in the tabular form. You can just generate it in the report. So once you click on report, you have the options what to include and what not to include in the report. So I'm just taking a random value that I would like to include into my report just for the demonstration purpose. And you can just save it in your file, and I'm just saving it in my desktop, and it will give me the report. It can be saved as the PDF as well. So this is the report that has been generated with the information that I have only selected. So the loads, the elevations view. So whatever I have provided the information, it has given me the report. So you all have the options to give the information for your tendons, the deflections, PT diagrams, the stress diagrams by just simply clicking on that particular icons. You will have all the informations. Like I mean to say, you can just like it is a software specifically focused for the beams and the slabs. For example, once you run this analysis and you just want to go back to your modeling environment, you can just click on the actions options available at the top, and you can just click on the interrelated data. Then it will again take back to the models where we have created. And you have the options like you can see, like if you want to go to the particular segment, for example, if you want to change the span geometry, you can simply go on the ribbon toolbar at the top. There are the options available for geometry, loading, materials. So you can just click on any of these parameters and it will take you directly into the part just to edit your model data. And you have the option just to hide and what to show all the information. So this is regarding the quick interface of the Adapt PTRC. So it is basically for like modeling of beams and the slab, and it works in a 2D environment. Like you can provide the input to your model data, and it will calculate all the information accordingly. So that was about the Adapt PTRC, but we'll also discuss quickly about the Adapt Builder. So build like Adapt PTRC is a 2D, but the builder Adapt Builder is 3D modeling and the analysis software focused on the design of entire concrete structure. We discussed, PTRC mainly works for the beams and the slab, but this Adapt Builder expands to include all the structural elements like the foundation, the column, the wall, and the complete building system. And yeah, you can carry it out the different types of the analysis like this advanced analysis and check for the serviceability conditions like the creep shrinkage, the long-term deflections, and more again in the Adapt Builder as well. And it can create the automatic and the code-based load combinations. And it also supports the Indian code as well as the international code. And when it comes to the reporting, Adapt Builder also gives you the detailed report, just like the PTRC, including all the tabulars and the graphical report. So here you can carry it out the different components like is shown on the screen, like it may be the shear wall, the column beam, and the slabs with the opening, the flat slab, and you can model the ramp or the like the foundation system. So these are the list of the project type. Like it can handle slabs of all kinds, like the one-way, two-way, or the flat slab, and the complex geometry also like the ramp, like I mentioned. So for foundation, it can model and design the mat foundation, the pile caps, the footings, and the grade beams. And it also works with the elements like the sloped columns or and the shear walls. So it can be used for the concrete project for all kind from that's of the different purpose like the it may be the residential podiums or the large high-rise towers of the mixed-use building, but your specific focus is for the beams and the slabs, then the Adapt Builders might be the good one. So Adapt Builders also includes the options for integrating with the other programs and between the Adapt Builder model, like you can share the level definitions, the geometry, the loading, and the metal properties, like between the Adapt Builders model, like, and you can also integrate your Revit model to the Adapt Builders in both way, and you can also quickly create the geometry by importing our DWG and the DXF file into the Adapt Builders. So we discussed about the builders and the PTRC. So you can see on the screen both Adapt Builder and the Adapt PTRC supports the range of an international design code in the Indian standards like the IS 456 and the IS 1343 ACI code, the Euro code, the Canadian, and the other code. The only difference is that the Adapt Builder also includes the support for the loading code like IS 875 and the 1893 for the seismic design. Because it is because like Adapt Builder is used for complete building modeling and analysis, but PTRC is more focused on the beams and the slab like I just mentioned. So it doesn't include the load generation code, but otherwise the design code are almost the same. So at a summary, you can see the difference. You can see the features of both softwares. And as a summary, so Adapt Builders provide the design environment for all the concrete structures, supporting slabs, beams, it may be the column, walls, and foundations. And it can carry out the punching shear design, the long-term deflections, and it can be integrated with the Revit and the DXF in comparison, like I mentioned, Adapt PTRC tools for the beams and the slab. Again, it can be used for one-way slab, two-way slab, and the continuous beam frame system. Like we see, it offers the tendons layout with the force adjustment, the PT recycling, and so both of the software handles both the bonded and the unbonded tension. So only the difference is, so this is only the difference in the Adapt PTRC that is specific for the beams and the slab. So this is regarding a license management of your Adapt software, like which can be managed through the Visa portal. And regarding the licensing type, the Adapt license is the cloud-based subscription license. Like it provide flexible access, like means you can add multiple users can be assigned under the single license and through this Visa portal, but only one user can use it at a time. So in the right hand side, you can see the snip of my Visa portal, and in the overview, you will see all the Visa products you are using. And in the user dropdown, admin can add or remove the multiple users under the single license. So this is how you can manage all of your license if you are already an existing customer of the Visa. So just to summarize like what we have covered today, we have started with an overview of the ADAPT PTRC for PT and the RC design, and got to know about its key features and the supported design standards. So during the demonstration part, we showcase a beam model, like its analysis process and how reports are generated. So we also, briefly understood, I hope, the difference between the PTRC and the builders, along with the licensing option. So, so since today was the introductory session, so in our upcoming webinars, we'll try to cover the specific topics in more detail, so that we can explore more deeply into the particular topic. So we'll display some poll questions here, and then we can take the few questions.
Okay, Giti, thanks a lot for that very insightful session. I hope it was the same for you all. So yes, we are displaying some more poll questions, and then we'll move on to some questions from your side. So if you have anything, if you want to ask anything specific, now would be the time to do so. You can either do it in the Q&A chat box that's on the top of your screen right now, and we will try to answer most of these questions during the session itself. If not, we will try to answer it after the session with your email. So as of right now, we don't have any questions. Kirti, I'll just move ahead and ask you some frequently asked questions that we get regarding ADAPT PTRC. So first of the most commonly asked question is, can we design column and shear walls in ADAPT PTRC as per ECI?
Yeah, thank you, Ashwin, for the question. So, like I mentioned in my presentation, so ADAPT PTRC is for the analysis and designs of the beams and slab. That may be both, that may be the PT and the RC beams and slab. But for columns and the shear wall, ADAPT provides another software called ADAPT Builder, like I showed, which is a full 3D analysis and the design software to model the entire concrete building system, including the vertical elements and the foundation. So basically, with the ADAPT PTRC, you can only design beams in the slab, but with the ADAPT Builder, you can design all of your components.
Thanks a lot, Kirti. So most of our clients also mostly do outsourcing work. They were wondering if they got the license in India, uh, can their clients who are usually from another country outside India also use the same license, and also does the license purchased in India support US design codes and other codes?
Yes, the answer is yes. Means the license can be, accessed from anywhere, since all the Visa and the ADAPT license are cloud-based flexible license, and it does not have any geographical restriction. Um, that means, like your clients, like any of your clients or the team member can use the same license from different locations, and that license can be managed through the Visa customer portal that I have shown during my presentation as well. Like you asked, if you procure the license from India, uh, there is an, I think, special India pricing. For this, you can get in touch with our sales team, and all the software functionality remains the same. And it include all the available design code in the software, including the American standards, with no limitation in the features.
Okay. Okay. We have a question from Mr. Rafiqul. He is asking that in stress check, is the section considered the contribution of MS rod?
Yes, so since we have defined the reinforcement as well, so you can set all of this. So basically, if you are talking about the pre-stressing values, then uh, can you just repeat once again?
So the question is, in stress check, is the section considered the contribution of MS rod? Does the section consider the contribution of MS rod?
Okay. Okay, maybe you are talking about the steel reinforcement as well. Like, yeah, so you have the, like, since you define all of your components within your model geometry, you provide the like the reinforcement for your top and the bottom reinforcement. So yeah, it of definitely adds some values in the stress check as well, and it can be clearly visualize it from the reporting sections. And but if you are but in the PT recycling, it will check for the stress check for your tendons, like the values we have provided, the initial stress and during the service stress values, whatever the value we have provided, then it will consider that stress and will recycle your components accordingly.
Okay. Thanks a lot, Kate. So with that, I think we can move ahead. We don't have any further questions. So if any of you want to explore the software hands-on and want to try the Adapt PTRC for yourself, you can use the trial version. So it will come with a full set of features and you can experience the complete capability of the software. You will also have access to technical support. You can directly contact us for any technical support related to Adapt PTRC or Adapt Builder. And the trial is available for 10 days, giving you enough time to evaluate your projects. To do so, either you can contact us directly or you can write to us at solutions. All of our details will be given to you in the meantime, in the end of the presentation. So please wait for that. So yeah, about the support and learning for RISA, at Acero and RISA, support is a priority for all of us. So in terms of support, you will get dedicated channels for via phone and email, and online help is also available. For the licensing, the license will be a cloud-based annual license. It will provide flexibility, and you don't have to manually assign the license. Plus, the license is not limited to one system per se, right? About learning resources, so there are a lot of webinars that we have conducted for Adapt Builder, which is a major part of Adapt family. So you can check that out on our YouTube page. We can also provide you with courses, tutorials, manuals, and knowledge bases as well. Right, you can explore the Risa Learning Center at training.risa.com and you can get certified with their trainings as well as stay updated with the software. So, coming to what is coming next, in the month of April, we have two webinars planned. So, one is for Risa 3D. Risa 3D is advanced software solutions for design and analysis of composite structures, and another one is Bluebeam, which is a documentation and collaboration tool for PDFs. Our contact informations are here. So if you want to note anything down, if you want to visit in our office, we are based out of Noida, in Delhi NCR region. Our office is in Sector 57. This contact number is our official number. We will be available Monday to Friday, 10 to 6 p.m. And you can write to us at solutions@acero.in and I'll make sure that we answer all your queries. So I understand most of you belong to the design and engineering group, but your team someone from the IT or procurement might be interested in the procurement of these softwares and knowing the commercials of these softwares. We have a very limited time offers for this. So please do forward these details to them and let them know that Acero is dealing with the software. They are providing very discounted pricing. And as you know, we are very active in our technical support department as well. So with that said, thank you once again, Kirti, for a very insightful session. And thank you all for joining us today. I hope that you'll be passing on all this information to your procurement and IT team, purchase and IT team, and we look forward to hearing from you. Alternatively, you can just fill that information in our feedback form, and we make sure that we connect with them and not you. Otherwise, our sales team will be forced to call you, and we understand that that is not something you are looking forward to. So yeah, with that said, everything from our end is completed. I think I thank you, Kiki, once again, and thank you all for joining us. We hope to see you in the next session. Thank you. Have a good day.
Yeah, thank you everyone. Have a great day.